everyone, myself Sravanthi, working as Assistant Professor in the Department of Data Science and Cybersecurity in MLR Institute of Technology. Today our topic is Syntax Directed Translation Scheme for Infix to Postfix. So here we are going to convert the Infix expression to the Postfix expression. So here we are going to discuss what is Syntax Directed Translation Scheme and what are the examples to convert the Infix expression to the Postfix expression. So first, here what is Syntax Directed Translation? So here syntax directed translation is nothing but, it is a combination of context-free grammar plus semantic rules. It is nothing but, it's a combination of context-free grammar plus semantic rules. The same thing is for the SDT. Syntax directed definition is also pointing to context-free grammar plus semantic rules. But coming to here in syntax directed translation, it is also a combination of context-free grammar plus semantic rules. But typically one condition is there. Here these are enclosed with flower brackets. In the RHS plat, it will be enclosed with flower brackets. So that is the difference for syntax directed definition and the syntax directed translation. It is used in compilers to convert expression from one form to another form using the semantic rules. Here in the semantic rules, here we won't, not only we will be having the actions or the values, including that we will be having the flower brackets that will be enclosed with some statements. When converting infix expression notation to postfix using SDT, we typically utilize a parse tree and apply specific actions during parsing. So, to construct or to convert the infix expression to the postfix expression, we are going to use or we are going to construct the parse tree. With the help of the parse tree, we are going to convert the infix expression to the postfix expression. So, one example, let's see. Syntax directed translation scheme for infix to postfix expression. So, the first example is A plus B plus C. So, here these are nothing but the productions which are there. Including these productions, there will be the flower brackets with some statements will be there. These flower brackets will be placed in the right hand side, anywhere in the right hand side. Okay, these semantic actions, these flower bracket, these statements can be placed in the right hand side, anywhere we can place it in the right hand side. So let us see one example to convert the infix expression to the postfix expression. E produces TR. E is producing T and R. E is producing T and R. So T is nothing but, again it is having the one expression is there, ID, print ID dot name, print ID dot name. So let me take here E produces T and R, T is producing ID and print ID dot name, print ID dot name. Okay, print ID dot name. So the next we are having is R is there. Here R is pointing to, there are two expressions are there. Epsilon is there plus T is there. So which one we need to take? So we need to take plus T. Why? Because here I am having more than one variable is there, A plus B plus C. So that is the reason I am going for this second production. R produces plus T R1. So plus T, what I am having after T, there is a flower bracket. There is one statement is there, print plus. So print plus, and next one I am having is R. Here R1 and here R. Just we are going to show the difference for the LHS and the RHS. Okay. So here next T. One identifier I got, one A I got. So the next one I have is ID. So T produces ID. ID print ID dot name. Print ID dot name. So ID is what I am having here. So just let me write ID dot name. Next it is going backtracking. It is print plus, no operation, and it comes here plus. And here T is there. T is nothing, R is there here. R we are going to produce it. So why? Because I got only two variables. A, B I got. I am having here three variables are there. So let me define one more variable. So nothing but plus T R1. Plus T R1. Okay. So T is nothing but identifier print C. Identifier print C. Next R produces epsilon. R produces epsilon. Epsilon is nothing but empty. It's completed. Okay, so now here identifier ID dot name. So what is here identifier for me? For the first identifier I am having is A. So ID dot name is nothing but A. A I have given. So what type of operation I am having here? Print. So let me print A. A is printed. So next, actually it is starting from top to bottom. It comes here. ID print is there. So nothing but A is printed. So again it goes to the backtracking. It comes here, plus operator. There is no action here. So it comes here. So what I'm having here, B is there. Why? Because id dot name. The second one I'm having is B. So that's why print B. So what I'm having here, print operation is there. So print is nothing but it displays the output. B is printed. So next comes here. What I'm having here, print plus. So AB plus. AB plus. It comes here, plus operator. There is no action. Okay, it comes here. What I'm having, C is there. AB plus C. So the next what I'm having here, plus. AB plus C plus. So this is nothing but the postfix conversion. From infix, by using the sparse tree, we are going to construct the infix, and that by tracing it out, we are going to display the postfix expression. So this is nothing but it is syntax directed translation scheme. So in the syntax directed translation scheme, we will be having some statements like print statements will be existing in the RHS part that will be enclosed in the flower brackets. Here it is there. This is enclosed in the flower brackets. So this is nothing but SDT statements. But coming to the syntax directed definition, we will be having just it's a combination of context free grammars plus semantic rules. So let us see one more example. 9 minus 5 plus 2. 9 minus 5 plus 2. So the starting one is I'm having is expression is there. So let me take expression. So what I'm having, the first symbol I'm having is minus is there. 9 minus 5 plus 2 is there. 9 minus 5 plus 2 is there. So let me take expression 1 plus term. Expression 1 plus term, because start symbol we are going to take. Expression 1 plus term. After term I am having a print plus statement. Print plus statement is printed. Okay, it is displayed over here. So the next one I am having is expression. Now what type of expression it is I am having? It is a minus symbol. I got plus, the end statement I got. Now next one I am having is minus. So let me take the second production. Expression minus term. What type of statement I am having here? Print minus. Print minus is there. So next I have term. So what I can display? I can derive expression. I can derive expression using term or term 0, 1, 2, 3, so on till 9. But here I am having is 9 is there. I got 3 expressions I got. So directly 9. So I am going for term. Expression is producing term. So in the term, which one I am going to take? 9. Why? Because my number I am having is 9. So 9. And then after print 9. 9 and print 9. 9 print 9. So this expression is completed. So the next one what I am having here? Term is there. So term what I am having? 9 is completed. So the next one I am having is 5. So nothing but term produces 5 and it will be print 5. Print 5. So nothing but 5, print 5. It's completed. Next it comes here. 9 completed, 5 completed. So the next leftover is 2. So next one is 2. So term 2, print 2. Term 2, print 2. Now we need to trace it out. We are going from top to bottom. It comes here, expression, it comes here until the bottom. Nothing but the leaf node. It comes here. 9 is there. So there is no action is going to be here. So here I am having print. So nothing but 9 is printed. So what it is should be printed? 9. So 9 is printed. So it is going backtracking. Minus, no evaluation. It comes here 5, no evaluation. It comes here 5. So it evaluates 9, 5. And it comes here minus, plus, no action. It comes here 2. And it finds here print. It finds here print. 2 is there. 2 is printed. And it comes plus is there. 9, 5 minus 2 plus. So the syntax directed translation scheme to convert infix expression to postfix expression, 9 minus 5 plus 2 is 9, 5 minus 2 plus. So this is nothing but the postfix expression for the given expression. So let me see for this one. 2 plus 5 into 3. So these are some productions with semantic actions are given here. So let us construct the postfix expression for 2 plus 5 into 3. So what are the things I am having? Here E produces E plus T, print plus, print plus. So the next one what I am having here is 2 plus 5. So 2 plus 5 is there. Here what I am going to have here, E is going to be reduced. So plus I got. The next expression I am having is star is there. So let me take here it as T. E produces T. E produces T. So the next what I am having here, T is nothing but I can reduce it to F. T I can reduce it to F. So F is nothing but F I can have is ID. T produces F. F produces ID. Print ID. Print ID. So next plus is there. Next T is there. So what I have here, T star F print star. Star. So next one ID 2 is completed, plus completed, here 5. Next. So next T is reducing. T, what are the things are there for T? T star F is there, T by F is there, T produces F. T star F, no more expressions are there. T by F, there is no division. So directly I am going to take it as F. So F is nothing but F produces ID. Next, print ID. Print ID. Next star. So here I have F. F is nothing but I am having it as ID. Print ID. Print ID. So this is nothing but the pass tree we have constructed. So what is ID? What is the first thing I am having? 2. So print ID is nothing but 2. Here ID is nothing but 5. So here it is nothing but print 5. ID. So what is the third one I am having? 3. Is nothing but 3. Okay. So let me trace it. It starts from top to bottom. It comes here. It comes here. It comes here. So this is my end of the statement. Print 2. So 2 is printed here. 2 is printed. So the next it goes backtracking, and it comes here and it has here 5 is there and it comes star. There is no action. There is no print statement is existing. It comes here 3. Next it comes here plus is there. Sorry, star 2, 5, 3 star. So the next it comes here plus 2, 5, 3 star plus. So the given expression is 2 plus 5 into 3. We are going to convert it into postfix. And the resultant it is displaying is 253 star plus. So this is the resultant one. So what we have discussed is what is SDT and how to convert the infix expression to the postfix expression using SDT. So here we are going to construct the pass tree. By using the pass tree, we are going to convert it into postfix expression. SDT is nothing but syntax directed translation scheme. It is a combination of context-free grammar plus semantic rules. But here in the semantic rules, the flower brackets, there will be some statements, print statements will be enclosed in the flower brackets that can be written in the right hand side anywhere in the right hand part of the given semantic rules. Thank you.